Daddy, want to slide?
Hello everyone, thank you for joining us at Ladies Who Code. For those of you who don't know me, I'm Laura. I'm just filling in for Tanvi while she's in London, but you'll see me at other Ladies Who Code events. And tonight we have a talk about Docker from Nancy here, who's a cloud worker. We're looking for senior developers, but just let us know if you're interested at Docker's careers. If you have any feedbacks or questions, email us, tweet, or you can find us on the meetup group at Ladies Who Code. This is our next talk, so this is the one for July. We had this talk again at, I think it was called 300 Seconds for at the Lovelace Day. Some people developed an app to keep sex workers safe, and they're going to talk about it in July at our next meetup. So tonight we have Nancy. She's a developer of ThoughtWorks. She worked on different projects, so she has a broad experience, and tonight she's going to talk to us about Docker, which she really, really loves. So I will hand over to her.
Cool. Thank you, Laura. Let me just switch over to my slides, which don't look remotely as pretty as as Laura's, but right. Hello, everybody. Let me introduce myself first, because people can never say my name. I'm Nancy. It's like a Nancy with an M, so that makes it easy. I'm a dev at ThoughtWorks. I've been here for about 3 years now. I call myself a full stack dev minus UI. I don't like UI. So that's not really a full stack dev. But anyway. Right, so Docker is something I've been playing with quite a lot for the last 6-8 months, and it's something I really, really, really like. So I am going to do my best to sort of give a good overview and sort of speak about how it is done on real projects. Firstly, show of hands, how many of you have worked with Docker before? Can I ask how long for? Like how?
For a project.
Oh, cool. That's cool.
It's for a project, but only a couple of weeks.
Oh, nice. Okay. So, have people heard of Docker?
Yeah.
Cool. So when I first started playing around with Docker, right? So I was in this office, and the way we sit, we just come and sit anywhere, and we have like Amy, who's our marketing representative around, and I was like, oh, Docker this, Docker. She's like, mate, why are you on about this Docker? Like, what is Docker, right? And she is not a dev, she's not a technical person. So I was like, how do you explain what Docker is to someone who's not technical, right? So I was like, okay. I was like, Amy, think about this. If you carry a bag around, right? And you've got specific things in your bag that are specific to you. I was like, what if you could buy a bag with the things that are specific to you, the contents of it that are specific to you with the bag? I was like, that is pretty much what Docker does. So she was like, oh, I totally get it. I'm going to do a talk on Docker. I was like, all right, go ahead then. Right. So moving away from that. So Docker is essentially a platform that you can sort of ship your application, your dependencies of your application, and it's completely operating system independent. So what that means is we have been on client projects where devs are using Macs, Linux, Windows, and we all know how much of a dependency hell it is getting your applications working consistently. So Docker is trying to kind of solve that problem. it is the only thing that Docker expects is to see a box that's got Docker enabled on it. So you can run Java, you can run Ruby, but all encapsulated away in a image. So in terms of, I will get into the terminologies Docker uses in a second, but before doing that, so Docker architecture, Docker uses a server client architecture. So what that means is you could have, there's a Docker daemon, which is your server that lives somewhere, which actually takes the heavy lifting of building images and speaking to the client. So the client basically is the only user interface to your Docker. So client goes and says, okay, go pull me this image from Docker Hub, go push this image, go commit this image. But Docker daemon or the server is doing the heavy lifting of building and managing images. So these are some of the terminologies that I'm going to probably going to be using quite a lot today. Image container. So container is an instance of an image. So image is basically a snapshot of your container's configuration. So this does not clearly show you what it is, but what I can do is do a demo, and sort of then you will start realizing the difference between the image and the container. So the container is basically it's similar as LXCs. So they are actually built on top of LXCs. So containers are just running processes that are alive and have some information on it temporarily. As soon as the container dies, if you've done anything outside of the image, and if it's not committed, you've lost that piece of work. Docker Hub is, so one other thing Docker does is uses versioning like Git does. So you could have your images versioned. You could, so you need some sort of a repository to sort of like store them and pull them down from. Docker Hub gives you that. You can have internal repositories as well, internal registries that can be built behind your firewall somewhere. But Docker Hub does give you, there are over 500,000 images on there. So I think there's always a common misconception of what Docker is. So Docker is not a replacement to a VM, and VM is not a replacement to Docker. I think they work really well together. So VM comes with application, the binaries, and along with that, it comes with a massive overhead of guest operating system and the hypervisor, which can go into good 10 gigabytes or even more. However, Docker does not need any of that because it shares its memory and everything else from the kernel. So the namespace, everything else comes from the kernel. So it's sharing your host's kernel to build images and run containers. Going into depth of how Docker works behind the scenes. So there's a concept of an image, which we spoke about. So what an image actually is a file system. That is all an image is. So in a regular Linux box, what really happens is there's your boot file system, which is similar to what Docker has up here. On a regular box, root file system is read only until it's booted. However, with Docker, it remains read only for the entire lifetime of Docker. What that means is every time there is, so Docker also uses this concept of union mount. Now, what that means, I'm throwing a lot of words at you, aren't I? Right. What that means is every image is nothing but a file system. So a file system can be layered on top of each other. And that is what this is. And there generally always is a base image. So your images are built off some base image. It could be Ubuntu. It could purely just be Windows. It could just purely be Java. But there is a base image that you build your images off. So when a Docker container is launched, it adds this layer, which is the read-write layer. What that does is, if you modify something on the image, for example, you've brought up a Ubuntu image and you want to change the etc host file, right? what that will be doing is moving that file from down here up there, modifying your changes for the specific container. So it's for that container that the file has been changed, and this base image is not affected. That allows us to sort of reuse this base image again because it caches it on your host. That is actually one of the features that Docker really strongly relies on and uses quite extensively. So Docker, apart from sharing its kernel, has its own namespace, and then that takes us to networking. So Docker has a Ethernet bridge, a virtual Ethernet bridge, which is your Docker 0. Actually, let me show this to you. It probably will be easier to understand. I've got so there are multiple ways you can download Docker on your box. One is if you're using a Mac, there's a boot to strap a tiny VM that has Docker on it. But then I just prefer using Vagrant because I've got a Vagrant that is running Ubuntu on it, and that's got Docker on it. So, so now if I show you, if I can type. So we can see an interface called Docker 0, right? So that's nothing but a bridge. What that does is every time a container comes up, it creates. Every time a container comes up, it goes and creates its own IP address, and that is connected to your. This is essentially your gateway. So this becomes a sort of pipe that connects to your Docker, and consider this white plain background as your host. So they sort of create a virtual subnet within each other, which makes one container completely isolated to another. Unless you explicitly specify, these containers will not be able to talk to each other. I've spoken a lot about images. I've spoken a lot about containers. How are these images built? There are two ways you can build them. One is using the Docker file, and the other one is using, well, you can pull down an image and commit on top and push. This is generally the recommended way of doing it because it is version controlled and you can sort of manage it. It's more manageable. What that does behind the scenes is the same. It actually adds a new image layer and commits that image. So let me take you through this Docker file, right? So the from is a mandatory field that tells you what your base image is. So here we're creating a base image of Ubuntu. We're going to build whatever we need on top of Ubuntu. We're saying update, run is a command that just runs any Unix command. It says, go ahead and update, install Nginx for me, and I'll create a file called index.html and, well, actually, no. Yeah, well, I'll create a file called index.html with this content. So what that should do, expose is another interesting thing where your containers can say, I'm going to expose this application on this port, and your host can, well, you can port forward that onto your host so you can actually see it from your box. I'll actually take you through this example so it just sort of makes sense. Right, so I've got a folder here called demo. Right, what I want to first try actually before doing that is I've got a bunch of commands that so let's try something simple, right? All I'm going to do is try and, so I've got a command there that says docker run. So what run does is launches a container from the image. So if you've got an image called Ubuntu, it's just launching that image essentially. And yeah, I'm saying started with a name called demo, and the -d is just saying run it in the background. Just run it in the background. interesting thing is I can actually make it do something on the container when it is coming up. So all I'm saying is display echo hello world for eternity. And we can actually see the logs of this. That's why I'm trying to do this. So I've done that. And this ID that you see is the container ID. Now, if I just Docker PS lets me shows me all the running processes. And that is saying, hey, look, this container that I've just tried to start has launched successfully. And it's been up for 12 seconds. And it is running something that you asked me to run. Now, what I can do is see that the hello world is happening. We can even tail that just the way we can tail logs, and you will see that constantly going up. Okay, so that was a very simple example of how you can run something on a container. Let's try and bring Nginx up, like how people worked with Nginx. Nginx is just like a HTTP proxy. Okay, I've got a Docker file, which I've spoken about before. So what that does is, okay, this was supposed to come in a bit later.
So we move it to the right. Please, right.
Oh, sorry, yes. Better?
Yep.
Okay, just quickly want to... Okay, so this is the exact same file that I explained earlier, spoke about earlier. So let's try and run that. So the way I build an image from that Docker file is simply using a command called docker build. This is where my Docker file is. So the dot just says, this is where my file is. Just use the default Docker file. And because I've already built it in the past, it does not redo all of it again. So this is quite interesting. So this is the image bit that I was talking about. So you know how I said Docker goes through this concept of building images on top of each other. These are all images. So if I get rid of, say, this command, which is run echo blah blah, it will not rebuild any of this because it can just reuse it can reuse the images it's got. Right, so let's try and run that container. Running that in the background again. And I'm just port forwarding it to 8080 to my box. I had exposed 80, so the Nginx was up on port 80. And that was right. So let me see if it's actually up and running. It's not. So if you notice, that ID does not live anywhere. Any guesses why? So I can open up Docker file. Oops. So there is one fundamental rule of Docker. All your applications, all the processes on your container have to be in the foreground. If they're in the background, Docker cannot live as a container. Because we've not started up a process in the first place, and we've not put it in the foreground. So let's try and do that so we can have a process running while the container is up. Basically, entry point is another command. What that does is that applies so that command is applied to the container. So it's saying when the container is up, run this command on the container. But everything else here is on the image. So that will remain fixed. Only your entry point is saying, okay, your image is now built. However, go into the container and bring this up. So this command is specific to the container. Okay, let's rebuild that image. Wait, we've got a new container ID. And let's try and bring that up. This is where demos go wrong. And let's see if that's up. Okay, claims to be up. And we said, hi, I'm in your container, didn't we? Let's hope we can see that up here. Way. So you can see how I have so I've got an Nginx process running. I do not have this running on my box. I did not have to download Nginx on my box. I did entirely in the Docker space. So these images are even available online on Docker Hub. So all I can just go and do is say, pull this image down, pull my SQL down, and I've got my SQL running on my box. Right, so moving on. So one other cool thing that you can do is, okay, it's cool. I've got a web service running. Well, it's not a web service. I've just got a static page up, served up by Nginx. I want to be able to. I shouldn't have to go change Dockerfile every time I make a code change. I should be able to do that dynamically as a dev. So if I make a change, it should be up and running. I shouldn't have to redo this process every time. Let's try and do that. So Docker has this concept of volume. What you can do is mount a volume on your host within the container. So the volume on your host can be where your files are. So you could have multiple index files with different content in it, and that should reflect straight away. So let's try and do that. I'm going to add a bunch of, just to save time, I had some stuff ready. Okay, so what that is doing is I already have a folder called conf on my local host, on my box. Well, when I say my box, I mean Vagrant, because that's where Docker is running. And I have some configurations for Nginx, so it serves up from a specific folder. So everything can be based off the container ID or the name of the container. You can associate names to the containers, so then you don't have to use these gobbledygoos that nobody can sort of recognize once they're running. Okay, so what that is doing is it's saying, start up my container on my box. That's what run is doing. It's saying port forward what is being exposed on port 80 within the container to my host at 8080, and minus V is the volume. So it's saying from the current location, go into files, and everything that is within files, go mount it on this location on the container. I'm going to run that. Really? Oops, my bad. I'm going to have to rebuild the image because I've changed. Every time you make a change to Dockerfile, you rebuild the image. One other thing that's probably worth showing is if I go into files, I already do have an index HTML, and that is just saying test blah. What I'm going to do is leave that in there. Okay. Okay, I need to kill. So because we already started Nginx previously and I've not killed that, I'm going to have to kill that first because I can't bring another up on the same port. I'm going to kill that. So I can start and stop containers. Once you stop containers, if you've formally gone onto the container and changed something, you're going to lose it. Actually, before I start that, what I can show you is I can actually go onto that container. So right now, as you can see, I'm root at Vagrant. However, using this command, which is exec, which started from Docker 1.4, lets me run commands on the containers, on the containers that are running. However, what I wanted to do was actually log in. Oh no, it is running. So yeah, that's okay. And now you will notice that I am root at the container ID that we've just tried to kill. So I am right now on the container, and ifconfig will tell you that I'm on a different network than I was when I was on Vagrant. Cool. Because you always run into scenarios where you actually have to get onto the container to make some sort of a change. All of that can be automated, but I think that was the reasoning behind exec coming in with the running container. Okay. I didn't kill it again. Right, so Docker PS will show us only one container that's running, which I actually don't even need anymore, so I'm going to kill it. So we've got no processes running. Let's bring the Docker up with a different content on index. And wait, that's the content we've just seen. And the interesting thing about this is let's go into the files, and we've got our index, and let us make a change so we can actually test the fact that it reflects straight away. So I've got rid of new, right? And we should hopefully see that straight away if demo doesn't go wrong. There we go. So this is one of the reasons why Docker is becoming so popular, because you can sort of work on the infrastructure that looks, well, you can work on the environment that looks similar to production, constantly making changes as a dev. A lot of companies have adopted that for this very reason. Because you all, like, how often have you heard of, oh, it works on my machine, but it doesn't work on XYZ environment? And that is one of the problems Docker is trying to solve. Make your dev environment look as close as possible to your other environments. Okay. There's one other thing I wanted to show you. So have you guys used MySQL? Yeah, cool. So you're familiar with that. What I'm going to try and do is I will actually also show you Docker Hub. So this is pretty much like, this is just a registry of all the Docker images there are. So if I search for MySQL, it will show me all the images that already live that you can just directly pull. So this sort of implies it's an official image. MySQL and a lot of other companies have done that with their products, where they just release official products because they're more maintained and supported. As you can see, it's got what 4.6 million downloads. You can see how popular Docker is becoming.
So is that like just an Ubuntu, and they've just in their Dockerfile live, like they've like installed MySQL?
Yeah, exactly. So actually, so you can't see the Docker file of an official image, but what I can show you is something somebody else has done. So if we look at the Docker file, you will see that it's based off in Ubuntu, but what they've done is done a bunch of handcrafting that we will end up doing either through some sort of configuration management tool or manually, which I don't think anyone should be doing. But yeah, it's all of that is hidden away, and it's an environment ready for you to just adopt straight away. As you can see, this user is creating a bunch of this person is creating a bunch of users. Well, it's creating a user called admin with some sort of a random password. So yeah, MySQL is ready to just log in.
So what happens if you want to use like a bit like that image and that image, like
together?
MySQL and something else?
I don't think you can use both. So within Dockerfile, you can't use both images like that. But what you can do is have a base image like, say, MySQL, and you can add changes on top of that. You can make your base image be that image. It doesn't have to be Ubuntu. But as a hierarchy, your base image will be Ubuntu, if that makes sense.
Yeah.
So yeah, that's how a lot of handcrafted images get created, and they generally get hosted internally, or there are private repositories. And if it's something that you're happy being open source, you can just load it up here. What is nice about Docker Hub as well is that it hooks up with GitHub and Bitbucket. It uses something called as automated builds. So what that does is every time you make a change to Git, it rebuilds that image. What I'm doing, the Docker build dot step, it is taken care of by a webhook. So it's quite handy, because you can also, if the building fails, they have their internal CI. So if the image is corrupted, you get the feedback straight away. You can fix that. It's quite nice. So let me try and pull down MySQL. So as a rule of thumb, official images are just what it is, like MySQL. However, if they're created by the community, there's generally a username / the image name itself. So I'm just going to pull down the official image, and that should pull down MySQL for me if I'm still connected to the internet. Okay, that's odd. See, demos never go well. Okay, let me just try and log in again. This is on my box and not the Vagrant. Okay, let me pull into my Vagrant again. Do you have any questions in the meanwhile while I'm waiting for this? There we go. Right, let's try again. Okay, yeah, so because I've tried to do a dry run, because demos always go wrong, it's telling me that I already do have the image and I don't have to pull it down. So there's another command that's very useful that you can use, is docker images. That will tell you all the images that are on your box that you've pulled down. And you will see that MySQL is on it. So let's do something. Let us run MySQL. So this will tell you generally most good documented image repositories will tell you how they are, how you can run them. What that is saying is Docker run. We've spoken about it. We've spoken about names. We've not spoken about -e. What -e does? Actually, now would be a good chance to show you. So what I'm going to do is do that. I'm going to call.
Can you increase the size?
Yeah, sure. Is that better?
Yeah.
Okay. Right. So what that is doing is passing an environment variable as you'd like it on that container. That is what -e does. So I'm just going to pass in an environment variable. And what they are doing, the reason they'd be doing that is because they're relying on your environment variable to set the password to be the way you'd like it for MySQL. You can instantly see how useful that'll be when you start building images of your own. So I'm just going to give it a password of test. And let's just run it. That brings up a container ID. So what that throws out is just a container ID. What I can do is, let's go on to the container itself. So what that command does is -c is interactive, -t is just attaching a TTY, and that's saying, give me a bash terminal on this container. That is all it's doing. And if I try and print environment variables, I should see this environment variable that I set up. And I'm on the container now. So I'm on the MySQL container, so I should just be able to go do that, right? And it asks me for my password. Bam, I've got MySQL. I didn't have to do literally anything. All I had to do was download MySQL and run one command. All this is cool while I'm meddling with. How can I now, your application server's container is going to be separate to your database, right? One other thing Docker sort of really advocates is try and run one process per container. So because they're trying to sort of move forward, leech on microservices. So if you have one container that's running a jar, yeah, and you want to connect your jar to a database, what you can do is link them together without even having to expose IP addresses or ports. Let's try and do that. I don't have an image that is running jar at the minute, but what I can do is the Nginx that we brought up, the image that has got Nginx on it, can link to database, and we can ping database from that image, and that should prove that we're able to do it. So if I go and show me all my images again, because I've been bad and not given any of my images names, except this guy. Right, so I have created this image. I'm going to kill the Nginx that's running. Okay, what I'm going to do is rerun the command I did here. Which was to bring up the Nginx. But what I'm going to do this time is attach a link to it. So what that link does, as I said, connects to containers. The way it does that is it goes and modifies etc hosts file on the container that you're linking to. So then it knows through hostname how to connect to the other container. So I'm going to say, the MySQL that I brought up was called some MySQL. That's what we've just named it for the ease. So what I'm going to do is say, link my Nginx with some MySQL and give it a name called DB. I just want to call this link between the two containers DB because that's what it is. And okay, I missed out okay, but it's up hopefully as expected. So what I'm going to do is go onto that container, sorry. I'm going to go onto that container and let's actually see if that's worked. So let us see if my etc host files have changed. Wait, we've got DB there. So I should now be able to ping to my database, and I didn't have to expose any IPs or ports, which to me tells me that when I do version control, in my application, in my configuration, I will not have to have hard-coded IPs in. I can have a hostname called db.local, which can be my alias, or db in our case, and that should work across all environments. So I can just ping db, which is the hostname of the other container. Cool. So there's one other interesting command called it's a flag on a command called privileged. What that does is allows your container to use the Docker daemon on your host. So it generally is recommended not to use unless your box that is running Docker is quite heavily secure, because you're sort of creating flaws in your file system to sort of cause hacks in a way. Cool. Jumping back. Right. So how can Docker? Where does Docker sit in this entire continuous integration of things, I guess? So if you look at general flow of things, you build, compile, you run some tests, you package something up, and you deploy it to somewhere. And if I speak in Java world, we'd be just compiling, run our unit tests, integration, and at some point run integration tests, and then package jar things up and deploy them on our, say, for example, CI environment or test environment. How would that work in the Docker world is if you're Dockerizing your application, which is you put your jar in a Docker file and build that up. Rather, you need to build that up and push that image somewhere to get deployed. So what package build possibly do as one of the patterns I've seen is you run the Docker build dot, as we've seen, at this stage. So what that will do is create an image for us and push it somewhere local, somewhere that is accessible for your project, I guess. You can have a local registry, you could have a internal registry running in your office, or possibly just use Docker Hub. What deploy will do is go and pull that image down and deploy it to a box. So deploy is Docker run, as we've seen. So Docker run, by the way, does the pulling and the running. It first looks for the image locally. If it can't find it, it goes and tries to fetch it from Docker Hub, and then it runs it. You can always, Docker pull will force it to pull any new changes that have been made to the image. So that probably is the only other difference. Cool. This is something I recently read, and I'm interested to try this out actually. So this is another pattern I've seen of how Docker can be used with CI. So what I've seen people do, actually, CI tools are one of the heavily used Docker usages. I personally have 2 images up on Docker Hub that run Go CD and Jenkins. So the interesting thing is, if you bring up your CI through Docker, and you want to do the previous step, as we've seen, of building and pushing, you need your Jenkins container, which is already a Docker container, running Docker within. Docker and Docker, ooh, I'm talking Inception. This is why Hans Zimmer should go off, right? With Inception. Right. So there are a lot of images out there doing Docker and Docker. I personally have some myself. What that will essentially do is, this is quite cool actually. When I read it, I was like, that'll be something really interesting to try out. So have you guys used Jenkins? Yep, okay. So say this is our Java application that we want to Dockerize. We Dockerize it. We say Docker build dot on our jar. However, our jar is going to keep changing every time a developer changes something and pushes, right? So what they have done is used the volume ability of Docker to, just the way we saw, this is a test website, a new test website, go to this is a test website. What they've done is done that with their entire workspace. So the workspace on Jenkins is again mounted onto their dev workspace. And what that is doing is this container, the Jenkins container, does not need anything else to run tests. It does not need JUnit. It doesn't need any of that. What they've done is just mounted everything that they need, run the test. If it fails, the container exits just like any other Linux process. So the fact that it exits with a 1 just tells it. I can never remember if 1 is okay or 0 is okay, but one of them is saying that we've failed. So I think I've not tried it, but I've heard it's a really good pattern to use. So probably something worth trying. Where have we seen people use Docker? CI, as I said, is one of the largest. In fact, I was at a conference a few months ago. There was a guy from Docker doing a talk, and incidentally, he mentioned the amount of people who are doing work around CI tools and things like that with Docker. And he mentioned Docker and Docker as well. So I was like, so it must be quite a big drift to it. So as I mentioned before, development, the ease of development, being able to do it as close to your production environment as possible, that is one of the other reasons. It's also used for like debugging capabilities, being able to manage your configurations well. Those are some of the use cases, and I will actually, these are some of the people who are actively using Docker, and there are some really good talks by these people on YouTube. Well, that's where I've seen them. DockerCon is on at the minute as we speak in San Francisco. It started yesterday, I think. So it's an annual event, and they've just released 1.7, I think. I just vaguely read something before starting this up, so I don't know much about it. So Docker is great, but it's not perfect. There are some security concerns that keep getting raised, but I think Docker as a community is actively trying to mitigate that. One of the other problems that I've personally had is any box telling me constantly that the device mapper, which is their file, which is what they use to sort of save things onto the host, is running out of memory. So you need to manually sort of clean some things up on the box that holds Docker images. So that's a personal pain point. But if I remember correctly, that's something they have claimed to have fixed, but a lot of people still run into it. So cool, thank you. If there are any questions, please do shout them out, or I'm around so you can come and grab me. Yeah.
Have you used Weave with Docker?
No, I haven't, but would you recommend it?
Well, no, I've just read about it, and it seems like it's doing a lot more than linking the containers.
In fact, one of the things I have in my agenda next week is I'm working with a client at the minute, and we have on our CI, we have a GoCD container that's coming up, and for our integration tests to run, we have a RabbitMQ and MySQL containers coming up as well. However, there's a lot of, we're using Chef to bring all this up, and it's a lot of pain to sort of manage these containers coming up separately. So one of the ideas that I want to try and implement is Docker Compose. So what that does is the ability to sort of manage all your containers together. So that will link with just a config. Have you tried Docker Compose?
No, I know it's a different solution.
Yeah.
But then with that, you actually need to know from the beginning everything that should be in your Docker cluster.
Right. It is something that I have on my list. I've not tried Weave now. Any other questions?
So I think when I asked before about if you wanted a container with MySQL and a container with like DB2 on it or something, and you said you have to build on one or the other. Is it? But then you mentioned later about linking them. So is that the way to go about it? You'd have one container with MySQL and one with DB2, and if you wanted them to interact, you would link them.
Do you mean one container having, say, Postgres and MySQL, and the container being able to link to both? Is that what you mean? Or
I mean, just if you want. So there's all these community like images that have, from MySQL and from
Yeah.
other companies.
Yeah.
One, if you wanted a box with a container or image with that, I want that one and that one.
So you mean parts of so MySQL with some specific configuration that comes from somewhere else? Is that what you mean?
Yeah, kind of.
So
In just another program on it, like MySQL's program, you wanted your container with some other program on it, but instead of you just manually overriding stuff in the build file.
That's where that's where you probably go and build your own image. If there are no images out there that sort of retrofit into what you're trying to do, the perfect solution would be to locally host an image.
Is it quite like common to find images that have?
Yeah, generally you will find images that do a lot of what you'd want to do. Yeah, it's if you don't find something, well, Docker community I'm sure is going to be very happy to find that image because somebody else is looking for it.
Yeah.
So yeah. Cool. Yeah, sure.
The underlying OS, I mean, I guess there's Windows equivalents for that. So could you do things like switching in and out versions of IE for testing with Docker?
Ooh, interesting. So
I'm doing a project at the moment. I'm trying to automate stuff, and I've got a load of different VMs for different configurations.
yeah.
It's horrible. I just wondering if I could switch them out really easily on one.
So
VM.
what directly relates to different versions of IE? So it's possibly some versions of your CSS, isn't it? Is that correct?
It's just checking. We're just sort of doing sort of spread testing just to make sure things.
Yeah, I think
kind of
you could definitely do that. So you could have different sets of code deployed to different sets of containers, and you can specify each container like to deploy specifically for a specific browser, if that makes sense.
Yeah. That might make my life a lot simpler.
In fact, that would probably be a great use case because we know VM take a great amount of time to like boot up, whereas Docker boots up in seconds. Cool. Anyone?
So you mentioned security concerns. What?
As soon as you told me that's what you're working on, I was like, I know this is coming. This is going to happen at the end of the talk. So one of the things that constantly gets spoken about is you generally when you go log into the container, as you have seen, you log in as root. You can change that. You can change that. But however, Docker daemon gives certain containers ability to sort of modify root files. Right. So other containers can then go and modify things that are on your host. But I'm hoping what they're releasing as part of this conference is fixing a lot of these, because a lot of noise has been made around these security concerns. So I think that is their number one priority at the minute, to sort of fix these.
Yeah, because that sort of one of our customers is actually looking at using Docker potentially, but they really need to keep the root access away from the people who are sort of monitoring and stuff like that. So
in fact, it also sort of largely depends on how locked down your host that is running Docker is. So it is quite reliant on that as well. So if you trust that host, I think you can fairly trust Docker containers that are running on it.
The things like something like Maven would Maven be able to build your Docker and the plugins for Maven to build Docker images as part of its packaging?
Not that I know of, but you could have a bash script that Maven can reference. And, no, I think the ability to sort of build images sort of lies with Docker Hub and Dockerfile. Cool. Thank you all for coming. I hope that was useful.
Thank you.
Yeah, thank you.